In this video, we will start by discussing the minimum distance between sprinklers and the minimum distance they should be placed from a wall. Next, we will explore a few practical examples of sprinkler distribution to make sure optimal coverage. Finally, we will look into the protection area limitations that can be handled by a single riser. Now, let us discuss the maximum distance a sprinkler should be from the wall. According to NFPA standards, the maximum distance from the wall a sprinkler should not exceed 7.5 feet or 2.3 meter. See, if you see the NFPA standards, it says that distance from sprinkler to wall shall not exceed 1/2 of the allowable distance between sprinklers, as we discussed before. See, for light hazard or on hazard, the maximum spacing between sprinklers should be 4.6. So the 4.6 half is 2.3 meter. Therefore, from wall, the sprinkler should not exceed 2.3 meter. And then, see, this is general rules. If you go for some like smaller rooms, like NFPA says, NFPA defines a smaller room which is having area less than 74 square meter. For such rooms, you can go maximum 2.7 meter. Okay, and then the minimum distance from the wall. The sprinkler shall be located a minimum of 4 or 100 mm from the end of the wall. You cannot place sprinkler less than this. And then we have one more rule which says that the minimum distance between sprinkler should be 1.8 meter. This is why this helps us in maintaining proper spray patterns and make sure that each sprinkler operates effectively during a fire. There are some examples given in NFPA for light hazard occupancy, how to distribute sprinklers in one room. Suppose we have only one sprinkler, then you can see the figure 1. So you can place a maximum of 2.7 meter from the wall. The second figure, there are 2 sprinklers in the wall centered between side walls. In the third figure, there are 2 sprinklers centered between top and bottom walls. In the fourth figure, we have 4 sprinklers. See how they're placing a sprinkler. You can go maximum 2.7 meter. But in the case of ordinary hazard, you cannot go more than 2.3 meter. Please keep in mind. This is only for light hazard occupancy. Now we know the maximum spacing between sprinkler, how much area they can cover, and the maximum distance from a wall. Now let's see an example how to distribute sprinklers in a room. So in light hazard occupancy, the area covered by one sprinkler is equal to 20.9 square meter. So first we should find total room area by multiplying length and width. So your total room is given by 15.65 square meter. Number of sprinkler required in the room is equal to total room area divided by area covered by one sprinkler, which comes out to be 0.74. So you cannot use a fraction sprinkler, so just round to figure, that is 1. So in this case, we need 1 sprinklers. Now let's go to ordinary hazard. So you know that area covered by one sprinkler in ordinary hazard is equal to 12 square meter. So number of sprinkler required in this room is given by 15.65 divided by 12, which comes out to be 1.3. So rounding off to 2. So here we need 2 sprinklers in ordinary hazard. See, in light hazard, suppose your area comes out to be more than 20.9 square meter, then you need 2 sprinklers. Same in ordinary hazard, the area comes out to be more than 24 square meter, then you need 3 sprinklers, and so on. So now we have taken some bigger room. So here the room area is 48.88 square meter. So if we divide this total area by 20.9, we get 2.33. So rounding off this to next good figure comes out to be 3 sprinklers. So in this room you need 3 sprinklers. See, you can see here the maximum distance from the wall, which is 2.4 meter actually here. So since it is light hazard, you can go maximum up to 2.7 meters. So here no problem. So in this room we need 3 sprinklers. Using same room as ordinary hazard, number of sprinklers required in this room is given by total room area which is 48.88 square meter, and divided by area covered by one sprinkler, which is 12 meter square. So now we get 4 sprinklers. So in this room we need 4 sprinklers based on area covered by one sprinkler. But here we have one problem. You can see located 2.9 from the wall, but you know that maximum distance from the wall should be 2.3 meter. So in this case you have to add 2 more sprinklers. After adding 2 sprinklers, this is how the distribution looks. Total we need 6 sprinklers by following all the sprinkler design rules. That is the area covered by each sprinkler and total maximum distance from the wall. So these rules, this distribution you can follow on all the projects. Like first you take the total room area, total the design area, and divide by area covered by one sprinkler. You will get number of sprinklers in each area or each room. Next design rule is protection area limitation by one riser. According to NFPA standards, one riser can typically supply sprinkler to cover a maximum area of 4830 square meter for light hazard and ordinary hazard occupancy, and 3720 square meter for extra hazard occupancy. So these limitations make sure that system can maintain adequate water pressures and flow during a fire. For larger buildings, you will need multiple risers to meet these requirements. The zoning approach helps in maintaining the system efficiency and make sure that each area receives the necessary protection. So suppose if your basement and which is having area more than 480 square meter, then you can divide into multiple zones. Like this example having 2 zone system. So far we have covered 4 design rules. Design rule 1, how to determine light hazard, ordinary hazard and extra hazard building classification. Design rule 2, we covered maximum spacing between sprinklers and the maximum area covered by one sprinkler. In design rule 3, we learned maximum distance from wall and minimum distance between 2 sprinklers. In design rule 4, we covered maximum area protected by one system riser. In coming videos, we are going to cover more design rules like number of sprinklers that can be placed on a branch line, sprinkler heads distance from ceiling, when we need to provide sprinklers below duct and cable tray, and then we will learn pipe size calculations using pipe schedule method.